Let's solve our first problem, which is integral of sine cube x dx. The way I would solve is first split this sine cube x as integral sine square x into sine x dx. I know that derivative of cos x is minus sine x, right? So I will use that and replace this sine x dx in terms of cos x, right? So let's just do that first. D by dx of cos x is minus sine x. So I can write minus d of cos x is equals to positive sine x dx. What I just did is basically bring this dx here and minus sign over here. So minus d of cos x is sin x dx, right? So I'm going to plug this for sin x dx. I'm going to plug minus d cos x for sin x dx, right? Integral of sine square x minus d of cos x minus integral sine square x d of cos x. So now my differential is d of cos x and the integrand is sine square x. So I need to convert my integrand in terms of differential. So that means I have to convert sine square x in terms of cosine. So convert it into cos. I will use the trigonometric identity cos square x plus sine square x is equals to 1, right? So I can write cos square x plus sine square x is equals to 1. So sine square x is 1 minus cos square x. Therefore, our integrand is 1 minus cos square x d of cos x and negative symbol over here. So just distribute this differential all over minus d of cos x plus integral cos square x d of cos x. Isn't this looking like our standard formulas? Minus integral dx plus integral x square dx, right? But we just have cos x. We know how to integrate dx and integral x squared dx. In the same way, we can integrate d of cos x and cos square d of cos x. So what do you think is our final answer? It is going to be minus cos x plus cos cube x divided by 3 plus integration constant c. This is going to be our final answer. Because integral dx is x, integral x squared dx is x cubed by 3. So since we have d of cos x for our differential, we're going to write in terms of cos x minus cos x plus cos cube x divided by 3 plus integration constant. Now, if we want to verify our answer, we can do one thing. We can derive this final answer to get our integrand function sine cube x. So if I derive cos x, it is going to be minus cos sine x. So it is minus of minus sine x. And cos cube x derivative is 3 cos square x. And derivative of cos x is minus sine x because this is a chain rule. divided by 3, and integration of constant is simply 0, so I'm not going to write that. So 3 and 3 would get cancelled. Negative times negative is sine x plus, and the sign in between is minus, so minus cos square x into sine x. I can take sine x common, sine x common, sine x off 1 minus cos square x. So sine x to 1 minus cos square x is sine square x, and this is sine cube x. This is our initial integrand. So we got our integrand when I derive the answer. So this says that our answer minus cos x plus cos cube x divided by 3 plus c is the correct answer. Let's summarize what we just did. So our problem is to integrate sine cube x with respect to x. So the first step I did is to split this odd power into one even power and sine x dx. Even power into sine x dx. So I know that I can write this sine x dx as d of cos x. So sine x dx will be minus d of cos x. And you can plug that for sine x dx. So I just did integral of sine square x times minus of d of cos x. So I brought the negative sign outside of the integral. So it is integral sine square x d of cos x. The next step, I converted this sine square x in terms of cos using the trigonometric identity. So I have written 1 minus cos square x for sine square x and distributed the differential d of cos x minus integral d of cos x plus cos square x d of cos x. And this is just looking like our integral dx and integral x squared dx. So we can apply our standard formulas, but we will just use cos x for x. So final answer would be minus cos x plus cos cube x by 3 plus c.